Hi, we are now starting polynomial division, but before we get really into the division part, I want to do some review to make sure that when you get to the monomial divided by a monomial, you have all the skills, and it's just honestly pretty easy. So because multiplication and division are closely related, they're actually the inverse of one another, I wanted to start by reviewing this stuff. Now, if you haven't already done the page, maybe turn off the camera. I did it again. Turn off the video and do it yourself, and then turn it back on and see what you get. Okay, seriously, turn off. Thank you. All right, so c to the fifth. Exponents always imply multiplication. So by the way, this part is called the base. It's also a variable, but when you're using an exponent, it's called the base. And obviously this is my exponent. And the base tells you what to write. So I'm going to put a c. And then the exponent, the little 5, tells me how many times to write it. 2, 3, 4, 5. And that's pretty much all there is to it. Right, so expanding. So then p to the third, or in this case, sometimes they'll say p cubed. It's going to be p, and you know what, just for fun, reminder that a big dot like that can mean multiplication just like the brackets can. And then over here, I wanted to just show you the difference that brackets make. With the brackets, that means whatever is inside the brackets, you write 5 times. So this is WT 2, 3, 4, 5. So it's kind of like that. The 5 is applying both to the W and to the T. It's almost like a distributive property. And for what it's worth, you could even have 5 W's and 5 T's. Doesn't make a whole lot of difference. This one, on the other hand, the 5 is only on the T, so the exponent only applies to that. So there's a W, but there's just 1, and then 1, 2, 3, 4, 5. Put those brackets. There we go. Okay, so remember that if you have an exponent with some brackets, it's whatever is in the brackets is written a number of times. So even if I had, let's say, 3x plus 5 to the third, that would mean 3x plus 5. It's my base. And another time, and then if all it said was expand, we were done. If it said multiply, basically what you do is you FOIL these two, and then take your answer and you multiply it by that one. I'm not going to do it because I don't have room. And truthfully, ta-da, this is division. I know you already know how to do multiplication. All right, let's look at this. Now, humor me. I think you're probably going, why did she do that? But you know what? I wanted to make sure you understood it. 10 divided by 10, and goodness, I hope you didn't have to use a calculator on that. 1 is 1 is 1. So anything divided by itself is 1. So then you know what? E divided by E is also 1. Because whatever this variable represents, so say this represented 5 today, that one down there is 5, and it's still 1. Same thing here, p to the 4th divided by p to the 4th is 1. And even when you have something weird, 15, a to the 5th, b, 7, anything divided by itself is 1. So the rule you need to remember, you knew that, but this can become important right away. It's real simple. All right, so the way I like to do math is I'm going to show you how and why the rule works, and then I'll tell you the rule. And my theory is that if you understand how it works, then if you get all stressed out during a test or something like that, you can always go back to the simple expansion. Basically is what we're going to do. We're just going to expand these like we did up at the top. And then do the question, figure out the rule and go, oh yeah, now I remember. And then you can apply the rule all the time. But it's kind of like you've got this safety net. You're really unlikely to mess up the rules. Okay, so expand and divide. F to the 6. 1, 2, 3, 4, 5, 6. Square. All right, now, I was going to use my highlighter, but we'll do this. These two, that's f divided by f. And anything divided by itself is 1. And then we can do it again. F divided by f is 1. So now we've got 1 times f times f times f times f. Well, if you want, you could write that, but truthfully, there's your answer that you'd normally write. This understood 1, it's always there. It's understood to be over there, but we rarely write it because you don't need it. All right, let's try the next one. Oh, why are you such big numbers? 1, 2, 3. How many G's do I need? Yeah, that's why I said I shouldn't use such big numbers. 1, 2, 3, 4, 5, 6, 7, 8. 2 D's. 1, 2, 3, 4, 6. Whoops, too many. Okay, now, usually what we do is we say cancel. So this D and this D are going to cancel out. But the key to remembering is it actually cancels out to 1. 95% of the time, that part doesn't matter, that you remember it cancels to 1, but there's the occasional question where, if you're not careful, I'm going to catch you, where you'll get, well, okay, where you're going to get caught, where it matters. So 1, and this cancels. And then 1, 2, 3, 4, 5. So what's left? There's a D here, and there's 1, 2, 3. G to the 3rd. Now, okay, I'm going to tell you, I'm completely lazy. I won't do this part. Let's see if there's a shortcut. What's the rule? I bet some of you already know it. So 6 and 2, and you got 4. Well, what are you doing at 6 with 6 and 2 to get 4? You're not adding, you're not dividing. But another way to do this, and I've seen this in textbooks, I don't do it. So the shorthand is you subtract your exponents. So this part I would just do in my head. Now let's just see if that works. Okay, D3, you know what, I'm going to put it over here again. No, not an equal sign. D3, G8 divided by D2, G5. All right, so 3 minus 2 and G8 minus 5. 3 minus 2 is D, it's 1. And G8 minus 5 is 3. So, ta-da! Look at that. Exact same answer. So my theory is on a test or something like that, I might do my first question like this, just to make sure I had the rule, I was remembering it right, that I'm going to subtract my exponents. And then after that, I would just subtract. And like I said, I wouldn't even do this step. I would just go 3 minus 2 is 1, and 8 minus 5 is 3. And ta-da! That's how you do division with variables. So let's do this one. 5 minus 2 is 3. 7 minus 7, well, okay, there's 2 ways you can do this. And I'm going to just cancel them because they're exactly the same, because anything divided by itself, like up here, is going to be 1. And then 2, uh-oh. They're not the same, so it doesn't cancel to 1. But remember, folks, there's a little understood 1 there all the time. So this becomes 2 minus 1 is plain old Z. That's pretty quick. But just in case some of you don't believe me, 1, 2, 3, 4, 5. Can you now see why using exponents is a beautiful thing? Can you imagine math if we had to write that stuff out all the time? That'd be crazy. 1, 2. Okay, so r to the 5th, 5 r's. You can also see when I'm doing this, I don't put the brackets to show multiplication because honestly, it just makes my work look really messy right now. So we got 5 r's, 1, 2, 3, 4, 5. That's r to the 5th. And then y7, 1, 2, 3, 4, 5, 6, 7. All right, z squared, 2 z's. Now we've got r squared, so that's 2. 1, 2, 3, 4, 5, 6, 7. And z. So cancel, cancel. That leaves us the r to the 3 that we have. 1, 2, 3, 4, 5, 6, 7. See, those all cancel out, just like we said there. You can cancel the 1 if you want, but whatever. And then those disappear, which leaves me with z. So it's your leftovers that appear over there. So the rule, and I kind of messed up, I guess I'm gonna have to write it down here, is when you divide, you subtract exponents. And that's it. I think division is actually probably the easiest of any of these, because for addition subtraction, you have to mess around and make sure you have like terms. For multiplication, you have to do the distributive property and all that, but all we're doing right now is we're just going to subtract our exponents. Easy peasy, lemon squeezy.